Hi, I'm Rachel, an AI agent trained by Orange Brackets, and I'll be your instructor for this tutorial. Today, we're building a friendly health and lifestyle recommendation system. The goal is simple. Take a few everyday inputs and turn them into practical tips you can act on. Exercise tweaks, hydration goals, meal habits, and then roll it all up into one lifestyle score out of 10. You'll enter basics like age, gender, BMI, fat percentage, how often you work out, the type of exercise, water intake in liters, and how many meals you eat per day. In return, you'll get clear suggestions like add one more cardio session, drink a bit more water, or balance your meals. Quick note before we start. This is educational, not medical advice. If you have health conditions or concerns, please check with a professional. There are many ways to build a system like this: rule-based, machine learning, or a mix. In this notebook, we'll keep it transparent with a rule-based approach. It's easy to understand, fast to prototype, and you control the logic. All right, let's get started. First, we'll set up our toolbox and load the data. Think of this as opening the project and seeing what's inside. We'll import the libraries, read the dataset, and take a quick look at the columns so we know what we're working with. Let's pull in our toolkit. JobLib will handle saving and loading our recommender when we deploy. NumPy gives us fast number crunching, arrays and linear algebra. Pandas is our table expert for cleaning and analysis. And Matplotlib's PyPlot, which we'll call PLT, turns results into clear, simple charts. All right, new phase, data handling and visualization. We'll get the data in shape, explore patterns, and then bring those insights to life with plots. Let's load our CSV into a Pandas data frame called DF. This gives us rows and columns we can explore, clean, and analyze. Quick sanity check. Let's list the column names. This shows exactly what fields we have, so we can reference them correctly in the next steps. If anything looks off, this is the moment to catch it. Real datasets often have a lot of columns, and we don't need them all. To keep things focused and fast, we'll select just the features that drive useful advice: age, gender, BMI, fat percentage, workout frequency, the type of exercise, water intake, and how many meals you eat per day. Fewer, well-chosen inputs usually lead to clearer recommendations. Clean inputs lead to clean output. Let's set up a list called Features. This will hold the column names we care about: age, gender, BMI, body fat percentage, how often someone works out in a week, whether they do physical exercise, their water intake in liters, and how many meals they have each day. And we close the list. Perfect. Now Features is a clean set of labels in the exact order we want to use them. Let's print the list to double-check everything's there and to see the final order at a glance. Before we move on, make sure this part makes sense. Now for the heart of our system, a rule-based function that creates recommendations and a lifestyle score from 0 to 10. We'll look at 5 parts: BMI, water intake, workout frequency, exercise type, and meal frequency. For each one, we add a quick suggestion and some points. Healthy ranges add more points. Areas to improve add fewer. At the end, we average those points into one lifestyle score. In simple terms, if you're underhydrated, we nudge you toward about 2.5 liters. If workouts are rare, we suggest getting to about 3 times a week. If you're already doing well in a category, we say keep it up. Because it's rule-based, you can tweak these thresholds anytime to match your audience or new research. It's transparent, explainable, and easy to maintain. All right, let's define our health recommendation function. It takes in a user dictionary, and I'll start a docstring so it's crystal clear what this function does. Don't worry if docstrings feel formal. They make your code easier to use and share. In the docstring, we'll spell out the inputs: BMI, water intake, workout frequency, exercise type, and meal frequency. And the outputs: personalized tips plus an overall lifestyle score out of 10. Setting expectations up front helps everyone. We'll create an empty list to collect advice and a score counter starting at 0. Each section will add points, and we'll average them at the end. Now, BMI analysis. We branch on the BMI range, add a tailored message, and award points that match the healthiness of that range. Under 18.5 nudges toward more calories, 18.5 to 24.9 gets a keep doing what works, 25 to 29.9 gets a gentle push toward more cardio, and 30 or higher is treated as higher risk. Labels can be refined later, but this structure is solid. Hydration next. We check daily water intake in liters and respond accordingly. Drink more if it's low, a small boost if it's close, or a high 5 for excellent habits. Better hydration earns more points. Workout frequency. If it's under 2 days a week, we encourage getting started. 2 to 3 days earns praise with a nudge to increase intensity. 4 or more days gets top marks. Consistency pays off. Exercise type. We look at the text in a case-insensitive way to spot cardio or strength. Either one gets strong credit, otherwise we suggest adding variety. Mix cardio, strength, and flexibility. Meal frequency. We capture the number of meals, guide under 3 toward 3 to 5 balanced meals, call 3 to 5 the sweet spot, and add a caution if meals are too frequent. The score mirrors those tiers. Time to compute the final lifestyle score. We average the total across the 5 sections, round to 2 decimals, and add a friendly line with the score out of 10 to the recommendations. Based on that score, we add a closing message. 8 or above means you're doing great, 6 to under 8 suggests small improvements, and below 6 signals it's time to adjust habits. Numbers become guidance. Finally, we return both parts, the list of recommendations and the numeric lifestyle score, so the caller can show the advice alongside the overall rating. Charts make the story stick. We'll show a simple bar chart of the user's health profile. Each bar is normalized to the same 0 to 10 scale, so you can compare side by side. We aim for realistic targets, BMI near an ideal range, around 2.5 liters of water, 4 to 5 workout days, and 3 to 5 meals per day. The title includes the lifestyle score, and each bar is labeled for a quick read. This is great for coaching conversations and progress check-ins. Let's define a function called Visualize Health Profile. It takes a user record and the lifestyle score we already computed. We'll track 4 categories: BMI, water intake, workout frequency, and meal frequency. Then we build scores on a 0 to 10 scale. For BMI, we reward being close to 22. Water is scaled against 2.5 liters, so hitting that target earns a 10. Workouts are compared to roughly 5 days a week. The sweet spot is 4 to 5. Meals per day is normalized around 4. To keep everything tidy, we clamp values between 0 and 10 using NumPy's clip. Time to draw the chart. We'll open a figure about 8 by 5 inches so it's easy to read. Then we plot a bar chart with our categories on the x-axis and those scores on the y, using a friendly color palette so each bar stands out. We'll lock the y-axis from 0 to 10 to match our scoring. Let's add a bold title that includes the lifestyle score, label the y-axis as health level, and finish with a light dashed grid to make the bar heights easier to compare. Now the finishing touch, labels on the bars. We'll loop over each bar and place the score right above the top. We'll center the text, nudge it up a bit so it doesn't overlap, and format it to 1 decimal place so it's clean at a glance. And we're done. Let's show the figure so the health profile pops up on screen. Time to test it out. We'll pass in 1 example person and see the recommendations and the score. As you read the output, ask yourself, does this feel like sensible, encouraging coaching? Try changing 1 thing at a time. Add a workout day, increase water, or adjust meals, and watch how the advice and the score respond. Alright, quick note. This is our sample user data block, so we've got something realistic to test with. We're building a user profile as a dictionary: age, gender, BMI, body fat, how many days a week they work out, the type of exercise, water intake in liters, and how many meals they have each day. And we close the dictionary, profile complete and ready to use. Now we pass that profile into our health recommendation system, and it gives us 2 things, a tailored list of tips and a lifestyle score we can show the user. Let's print a clear header so the results are easy to scan, then we'll list the suggestions right underneath. We'll loop through each recommendation and print it with a simple dash in front, clean, friendly, and easy to read. And that's the beauty of a rule-based recommender: clear, interpretable, and human-friendly. It turns simple inputs into practical steps without a black box. In real projects, you can extend this with sleep, steps, calorie targets, or stress levels. Later, you can add machine learning for personalization while keeping the rule-based layer for safety, clarity, and quick wins. Remember, these are general tips, not medical advice. Always consider individual context. Alright, time to switch to visuals. Let's turn our results into something you can grasp at a glance. We'll call our Visualize Health Profile helper, pass in the current user and their lifestyle score, and let it draw the chart, so we can quickly spot strengths and what needs attention. Let's make this portable. We'll save the recommender so you can load it in a web app, a chatbot, or an API. That way you can serve instant recommendations without running the notebook each time. This small step moves you from a notebook demo to something you can share and deploy. Nice work. All right, time to package our recommender for deployment. Let's save it so other apps can load and use it. We'll save it to disk as a compact pickle file named healthlifestylerecommender.pkl. That way everything it needs is preserved, and we can reload it later to serve results fast. And let's print a friendly confirmation, starting with a blank line for readability, so we know the save worked and exactly which file to look for.